Section 1.5. Thought about skipping this problem here, but this one is really, really good. Tougher than what you're used to by far. So far it's been warm up, warm up, warm up. And remember. And all of a sudden you're going to see a different type of problem, a different level of difficulty. So let's get started. This problem I made up. The problem that you're going to be assigned in your homework is easier because the numbers turn out nicer. I just made this up and I didn't really check into it too deeply, but you'll get the point. So they're going to give you a rectangular cardboard box, and they're going to say the top is open, so that means there's only 5 sides to this thing. And they tell you the volume of it is 3,200 cubic centimeters. That's what CC stands for. Remember, the volume is length times width times height. Then they give us some information. You can see I've labeled this width, length, height. The length of the box is 3 times the width. So we've got the length and the width being connected mathematically. You guys have been there, done that. So I'm going to call the width x. And I know that the length is 3 times that. And they don't give us any comparison to how the height is connected to the length of the width. So we have to introduce another variable, h, for height. So we have 2 variables. Now remember, if you're going to solve an equation with 2 variables, you need 2 equations. Remember systems of equations? This is going to just be way more complex than what you guys are used to, but I'll talk you through it. So we're going to start with this formula right here, connected to this, length times width times height equals 3,200 cubic centimeters. So length times width times height. So I'm going to go 3x times x times height has to equal 3,200. I'm going to clean that up a little bit. 3x squared height equals 3,200. I'm going to stop there. Let's read the problem. It said, what height, so it's all about this, will make the surface area. See, this is a whole nother formula. See, this is why we need 2 equations. They're giving us 2 equations. Here's equation number 1. I know it's weird looking, but don't panic. Surface area is just a whole bunch of rectangles. In other words, length times width. And so we've got the bottom of it. So I'm going to write this. I'm going to make a line here. This is volume stuff. And now this is surface area stuff. So I got the bottom of the object, 3x times x. And there's only one of them because there's an open top. And then we've got this side right here, which is 3x times h. But there's 2 of those, 3x times h. And then we've got the front of the box and the back of the box, which would be x times h, but there's 2 of them. So it's 2 times x times h. So I'm going to clean this up. I'm going to put surface area equals 3x squared plus 6xh plus 2xh. Notice we've got like terms here. So surface area equals 3x squared plus 8xh. All right. We have 2 equations now. The problem, listen carefully, says what height will make the surface area, so they're talking about the surface area, what height would make the area as small as possible. So there's a lot going on here. So what we're going to do is we're going to use substitution here. I'm going to solve for h in this one by dividing by 3x squared, divide by 3x squared, and I'm going to plug this in because h equals 3,200 divided by 3x squared. I'm going to take this and I'm going to plug it in for that. So the surface area equals 3x squared plus 8x times the height, which is 3,200 over 3x squared. I'm going to clean this up so I can get 3x squared plus, I might have to cheat here, the x's go bye-bye, one of them. That one goes bye-bye, and then there's one in the bottom. And this would be 2,400 plus 1,600 in the top. So that'd be 4,000 in the top. And that 3 stays down there. So this is the formula for the surface area. Now, I know the problem talks about what height will make the surface area as small as possible. So this is where we're going to use Desmos to help us find that, but this gets a little tricky. So I want you to understand that if you go to Desmos.com and you type this in, you're going to get a really weird equation. I'm going to pause this and show you what I mean. Okay, so now this problem turns into your ability to understand how to interpret this graph. Now, when I type this in, remember, x represents the width, but the surface area is in terms of x. So what that means is my x-axis is my width, and then my y value, this, would be my surface area. So this is my width of the box. That results in this surface area using that formula. Here's the twist. The problem is asking what's the height that will make the surface area as small as possible. Well, we now know that x being 6.057, we're just going to round it and say x is 6 just to simplify things. So when the width of the box is 6, it minimizes the total surface area. It's a really weird graph. This just goes down forever. This goes up forever and ever and ever. Then it comes down and goes up. This is called a minimum. That's showing us the minimum value for the surface area. So now we know x is 6 right here. But the problem wants us to talk about the height. Well, we've got this formula that we created earlier. So now all we got to do is plug this 6 right in here, square it. So that's 3,200 over 3 times 6 squared is 36. So that's 3,200 divided by whatever that is, 90 and 18, that's 108. I don't know if I calculated this yet or not, so let me pause it. Come on, there we go. Okay, I did. This is 29.62. So that's the height of this box that minimizes the surface area. Yes, there's a lot going on here, but there's only one homework problem like it. Do your best. You can rewind this and then connect it to your actual homework problem. Okay, so again, the author's just all over the place. And now the author wants us to remember one of our old geometry problems, and that is if we have a right triangle, we draw another right triangle within it. Triangle ABC is going to be similar to CDE. The bell just rang. Oh my goodness, class is about to get started. All right, let me finish this. So this sets us up for similar triangles. We're going to start with the small triangle. This side here over this side equals this side over the entire side. So 16 plus x. So now I'm going to cross multiply 12x, cross multiply this way. 80 plus 48 is 128 plus 8x. And then you just solve for x. I'm running out of time because my class is about to show up, so I'm going to go to the next topic. All right, so now we're talking FOIL. How do you do these? Well, you're just going to go 3x plus 9, 3x plus 9, because that's what you do when you square a binomial. You cannot square this and think you're doing it right. So 3x times 3x is 9x squared. Outside is 27x. Inside is 27x. And then last is 81. Add these like terms, 9x squared plus 54x plus 81. There's my answer. Last little portion of this pre-lesson. We got ourselves our 30, 60, 90. If you remember, this is x, and you have to double it to get this, and you have to multiply that by the square root of 3 to get that. 45, 45, 90, these two sides are the same. You have to multiply by the square root of 2 to get there. Now there's a twist, and that is if you have a 45, 45, 90, and they give you this, you have to divide by the square root of 2 to get there, divide by the square root of 2 to get there. So there's your little warm-up for your 30, 60, 90s and your 45, 45, 90s. They're going to expect you to remember this stuff. That's it for your little warm-up for section 1.5. Good luck.